Hi, my name's Robby Galletta. Thank y'all for visiting my site. What we've done here is I'm an inventor, and naturally I've invented a new way to dissolve oxygen in the water. It's critical because, well, of all the problems we have in ecology right now, one thing, man's very presence is causing a great deal of problems because we concentrate our civilization right along the coast, and unfortunately we concentrate all our daggone waste, and everything winds up in our rivers and streams. Nature's way of dealing with that is with either plant life, and then the bacteria that comes to devour the plant life uses up all the oxygen. And we have a problem with low oxygen content in virtually every type of civilized setting. Now what happens is, in the past, the only way that aerators have worked, they either threw water up in the air or they blew bubbles down, and basically that works on molecular pressure differential or osmosis. And in the real world, what happens is we can only get just so much oxygen in a given cubic foot of water. Now what we've done is come up with a fast, inexpensive way to put a lot more oxygen in the water. And more importantly, especially in a wastewater environment or anything like that, we're able to actually place the oxygen where we need it, inline in a pipe, at the bottom of a of a river or a stream. If I'm an oil company trying to clean up an oil slick or tar balls, when I put my cocktail of enzymes down at the bottom, I can put an aerator down at the bottom with it and create an oxygen plume so I don't kill the fish and everything with my cure. Anyway, being able to target large quantities of dissolved oxygen in water without wasting it as far as bubbles or other wasting energy is critical. And here's what we've done. Rather than throw the water up or blow the bubbles down, we actually cast a dome over it. This is some of my original drawings that I did way back in 2005, and you'll see the same thing throughout. Basically, it's a set of interleaved wheels underneath a pressurized dome. Now this one here actually works. This is a submerged unit. It acts like a diving bell. It can sit at the very bottom of the of the estuary where it needs to. What happens is we put it down there. It actually floods with water just like a diving bell would. We pump air to it. We push the water down until we achieve our level that we're looking for, which is about amidships of the rotors, and then we start the rotors turning. Now in a minute I'm going to show you the prototype here, and you'll have a better understanding. Now here we have it inline in a pipe. And here we have it in a free-floating in a dredge type arrangement. Now these can be scaled down as small as a wash tub for a golf course pond, or as big as a barge for the Mississippi River. Basically it looks like this. This is the artist's conception. This is a submerged unit. This is inline in a pipe. And this is a self-contained, remote piloted. And there's going to be something else that this thing will do, but I'm not finished with the patent work on that yet, so that's going to be a tease. We're going to have to find that out. Now, if you would, we're going to walk over here and look at the machine itself. Tony, if you would. Now, these are the rotors. These are some spares. We actually built some spares. Now, basically, what these are, this is a set of scoops, literally. One set of rotors actually brings air down. The other set of rotors gathers water. These tiny holes right here are actually designed to create either microbubbles or water jets, depending on where they're at in their rotation. Now what happens is, our initial rotor comes in, it grabs the water, and this creates microjets of water coming out of here, highly agitated water. And then our next rotor then interfaces with that. It makes microbubbles, which interact with those highly agitated water currents. So basically, we're always bringing oxygen-starved water into an oxygen-rich environment. But here's the key. There's a thing called Henry's Law, that if we add pressure, it's the same reason that you have like a pressure cap on your radiator, but if we add pressure to that water, what we can do is we can dramatically enhance the amount of gas it will hold. So for a few moments, or while we're doing this, we want that water to be at as much pressure as we can. And that's why it's so important in this device, we can actually make it work at the bottom of a riverbed, or at the bottom of the ocean. Really, it'd work in the Marianas Trench if you got enough air pressure. But the deal is this: we can put the oxygen where it'll do the most good, not where it dissipates out, and not where at the surface where it only holds 9 parts per million. Well, we can be at the bottom where it holds much, much more. Over here, this is the machine itself. This is the prototype. This is the inlet side. This prototype is designed as a flange, and we can basically, this will have a screen on it, but I can take this flange off and I can put this inline in a pipe. And because it's dramatically overbuilt, but it's done in such a way that we can actually observe what's going on in here, and we can use it in a number of different ways. We can actually take the same prototype and make a submerged unit out of it. We're going to test it in a swimming pool first, and then we're going to a wastewater plant pond, and we have an oxygen depleted pond we're going to try it in. Because the deal is, right about now, the standard, it appears to be about 7 pounds of oxygen per hour per horsepower. I think that we can dramatically beat that. Okay, and here's in other words, imagine if we could take one 20 horsepower aerator and replace 5 20 horsepower aerators. We're going to try to do just that. But the bottom line is, even if we dissolve the same amount, it doesn't matter. The fact of the matter is that we can target where we want the oxygen to go, anywhere, any place, without throwing water up in the air or blowing bubbles down. That's critical, because here, imagine if we have a wastewater plant next to a golf course, we can aerate the wastewater plant without making any smell. We don't have to have the windsock. We're not throwing fecal coliform and all kind of other stuff up in the air. Now we're going to walk over here. This is a control pressurized dome. This again, down here we're going to use ballast or whatever. This device was actually built to do any number of things, all the capacities. Guys, could you open the domes, please? We're going to open the dome. Thank you. All the way back. All right. These are over-the-counter dry systems, basically. We're going to walk around here, and I'm going to show. This allows us, by the way, we can change our configuration with an overhead crane. We can be in the water. We can change the number of rotors, how much they interface. See, the secret is, guys, with this one here, if you'll walk with me, tell me, it's right here. It's right here. This is our inlet rotor. We have a 3-rotor array right here. Cue yellow, please. Cue yellow. Now what happens is, when this rotor starts up, now we're going to be running relatively small. We're running at 1/3 the rotor's power right now, 1/3 speed. Basically, we draw the water in, and we're going into this mixing chamber right here. All right, this is critical. Now imagine these domes are closed, and this supercharger. And I can also take air from above. This port right here is made so we can block off the supercharger port, and we can take air from the surface if we run this submerged. And they'll come and test on that too. But anyway, cue red, please. What happens is this: we now we're drawing the water in, and right here is where the mixing occurs. Okay. Now I can be gentle like this. We're moving relatively slowly. I can spread those rotors out, see, because we don't want to beat the water too hard, or we might have a situation where we've got flocculants we have to protect and things like that. But the bottom line is, I'm basically bringing oxygen depleted water up, and I'm bringing microbubbles down in a pressurized environment. Cue blower, please, Dan. Now what happens is I can source my air here, and it'll get loud in just a second. Now there's a stack that comes up here in a big air filter. Alright, then shut down the machine. All of them. Now this is the short version, guys, of what we do. Understand this. I'm a mechanic. I came from the motorsports industry, and I got into the daggone wastewater industry after 9/11, and I got to see some things, some truly fabulous scientists, some great men and everything, and what they're doing is they're working with the tools they have. I'm not a scientist. What I want to be is I want to make tools for the scientists. These guys have come up with these wonderful enzyme packages that'll devour just about anything. We can dissolve tar balls in the bottom of the Gulf of Mexico, but we can't do it unless we have an oxygen supply for that enzyme package. Well, what we've done is build a machine that we can give an oxygen supply just about everywhere. One of these machines, or machines like this, sitting in the bottom of a daggone river channel, we can literally create a plume of oxygen-rich water going downstream, and we can reinvite the migratory patterns of our aquatic life. We can help them. Because I learned this boat racing, because when we had the powerboat races going on, the fish came to where we raced. So I hired an environmental scientist, and he came and we started doing tests of that lake. Well, where we were raising, the oxygen content raised up, and guess what? Those fish didn't care about the noise in them boats. They didn't care about anything. They cared about, A, we weren't putting any pollutant or noise underneath the water, and B, we were dissolving oxygen. So guess what? We had the fish on our side of the lake, and in between heats at the boat race, all the fishermen came to fish where we were at. Here's the deal, guys. The fish, the aquatic life, will go where the oxygen is. We can help change the direction. We can undo some of the incredible damage that we've done. Machines and machines like this can help. It can help a lot. Check us out, guys. We're going to be doing a lot of stuff here lately. We're going to test this week. We're blessed to be able to even pull this off in this economy. And we're not affiliated with any government issue or nothing like that. We're just we're a small group of believers trying to make a good thing. Thank you very much.